I'll show you how to use Geogebra to calculate the area between two curves. So first of all, we need to put a couple of functions in. So cubic x minus 4, x minus 6, and I'll graph that. We can see there's a nice cubic there, and remembering that we can reposition and we can change the scale if we need to. And the second function, I'll put a quadratic in here, so x equals, and we'll make this a nice simple one, x squared, let's try plus 10, oops, x squared plus 10, and we'll graph that. And we can't quite see it, but there is a second intersection, and there it is. So we can see where this cubic function and this quadratic function intersect in three different places. So we want to calculate this area here, and then we'll calculate this area here. And we do this by first of all finding the coordinates of the three intersection points, one here, and one here. And we do that by using this function here, intersect two objects. So we click on intersect two objects, and then click on the two curves, and we get the coordinates of the three intersection points, A, B, and C, and the x values become important when we're calculating the areas. So now to calculate the area, we use the integral function, and we just type the word here, integral, and we can see the menus come up down here, and we have two functions, a start value and an end value, so we choose the integral between, and function 1 is f of x, function 2 g of x. The start value is the x value for a, so that's minus 1.71, and the end value is 2.83, and then we press enter, and we can see the area calculated there. And here it is, this area here, 113.59 is the area between these two curves, starting from the value of x for A, ending with B. Now we do the same thing to calculate the area here. Down here and type integral. And once again, we find the menu, function, start, end, integral between. Click on that. The first function again is f of x. The second function is g of x. The start value is 2.83, and the end value is 7.88. Press enter, and we get the area again. However, this time notice that it calculates this as a negative value. Now, of course, area is not a signed number. We can't have negative areas. And so if you were asked for the area, you would say the answer is 151.95. Numerically, it works out this way because we used f of x, which is underneath, and subtracted g of x, which is above. In effect, we subtracted a higher number from a smaller number, and that always gives a negative. However, if I just hide that for a second, and I go back and I calculate in the other order, and so integral between, function, but this time I do g of x and f of x, same start value, 2.83 and n value 7.88, and I'll press enter. We can see now we get the same numerical answer, but now it is positive because this time I subtracted the higher one from the smaller one, and that gives me a positive answer. But you don't actually need to worry about that when you're calculating areas between curves, so long as you know where the crossover points are and you calculate between those crossovers and take the absolute value. Make sure that each answer is positive. So that's using GeoGebra to find the area between two curves.